Welcome students to lesson 13 of the natural hazards topic. In this lesson we're going to be exploring why not every tropical storm is equal, why some tropical storms are more to be feared than others. In the previous lessons we've looked at how tropical storms form, what they are and where they are found. In this lesson you're going to understand how we measure them. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10, answer the questions from memory and then mark your answers. Game time. 1. They travel northwest in the northern hemisphere. 2. The latitudes 5 to 15 degrees north and south of the equator. 5 to 15 is fine. 3. The calm center is called the eye. 4. The lowest pressure and fastest winds are found in the eye wall. 5. 400 to 600 kilometers, although based on some satellite readings, storms have reached even beyond 600 kilometers. 6. Condensation releases heat. 7. Foundations made from rubber absorb seismic waves. 8. On the island of Sicily, Mount Etna is monitored. 9. At destructive plate boundaries, oceanic crust subducts, where plates come together. 10. About $5 billion. That's the impact of Nepal's earthquake. Give yourselves a mark out of 10. If you got 8 or more, awesome. You've really understood these questions. Any questions that you got wrong, test yourselves on them repeatedly until you've memorized them. To introduce the idea of how we measure tropical storms and the differences in the damage they cause, I'm going to show you a video and some questions. Use the video to answer the questions. Trees, look at the speed of the wind, look at the pink insulation within the roof. What's the roof here of the blue building? Look at the roof again, look at all the debris and the material flying through the air. So look how fast the wind is, it'd be impossible to stand up out there. So use what you saw in the video to answer the questions. So number 1, describe the damage that you saw. Well, you should have said you saw roofs and homes being torn apart, insulation flying out, the wind tearing down walls, sand and other material flying through the sky, leaves and branches being torn off trees. These are the kinds of things that you may have described. 2, suggest what could have been done to prevent this damage. Well, you may have said that you could have built the houses and other buildings stronger, more resilient to the wind. You may have said the roofs could have been tied down, or the trees' branches could have been cut. Any of these would have been suitable. You may have said that the windows may have had shutters put on to prevent damage to windows. As you'll see in future lessons, these ideas and many others can be effective for reducing the damage. 3. No one was killed in these buildings. Why do you think that was? Well, no one was killed because people evacuated before Hurricane Michael arrived. And they evacuated because they knew it was going to hit that area. In future lessons, you will understand why people are able to predict hurricanes and tropical storms and what they do once they know that they're going to be affected by them. 4. What decides the strength of a tropical storm? This wind speed is almost entirely decided by the difference in air pressure between within the tropical storm and outside it. And that in turn is determined by the temperature of the water and the wind shear. Warmer waters mean faster rising air, meaning greater spinning of storms, meaning lower air pressure, meaning faster winds, and therefore determine the damage of the storm. So, this lesson, you're going to learn how we categorize tropical storms based on their strength and what the different damage levels are of these different categories. From this, you will be able to understand why people react in different ways to different types of tropical storm. So how are tropical storms measured? Well, they're measured using a scale called the Saffir-Simpson Scale, and it has 5 categories for them, where 1 is the weakest tropical storm and 5 is the most powerful. All tropical storms in history fall within these 5 categories. So let's start from the bottom. At category 1, the wind is blowing between 74 and just over 90 miles per hour. Leaves are torn off trees, but buildings generally remain structurally sound. Roofs of well-constructed buildings and windows should remain in reasonable condition. Though, if objects are flying around, such as branches, and they hit windows, these may be damaged. The key problem with Category 1 hurricanes are the loose debris objects, such as branches and leaves, that are strewn around in the street that get blown around by the wind speeds. Category 1 hurricanes usually do not lead to massive evacuations of cities. Category 2. Now the wind is blowing at over 90 miles an hour. More branches from trees are being torn off. Some trees will even be blown down at this point. Windows may start to break if they are not protected by shutters. A couple of tiles may be ripped from roofs now. Weaker homes, warehouses and tents certainly will be destroyed. Now people consider gathering supplies within their homes and cutting down any extra long branches and removing objects from the street. They may close the shutters on their windows and ensure that their roof is secured. Category 3 storms, now you're getting serious. This is over 110 miles per hour. Any windows that are unprotected will be destroyed by these wind speeds. Trees will be torn apart. They'll often be seen flying through the air. Loose objects, even large objects, such as bicycles and other large objects that are left around in the street or in driveways or in gardens, will be flown into the sky. It is extremely difficult to stand in a Category 3 tropical storm. The roofs on buildings, especially if they aren't very strong reinforced roofs, may start to be torn off in Category 3 tropical storms. Category 3 is generally common in the warmest oceans in the world, off of the Caribbean in the USA and the West Pacific Ocean. Category 4 is devastating. Hurricane Katrina, when it hit America in 2005, the most damaging tropical storm of all time, was a Category 4 when it hit. This leads to huge storm surges of up to 5 meters. It tears roofs off buildings, even secure ones. Almost all windows are shattered. Trees are ripped off from their roots. Even cars begin to move now. Category 4 is more than 130 miles an hour, and now you're into the kind of storm that can cause billions of dollars of damage and kill hundreds of people. The storm surge from a Category 4 tropical storm can flood many miles inland due to the very low pressure beneath the storm and the high wind speeds. And finally, at the very top end of the scale, the most devastating tropical storms are Category 5. Roofs that are not reinforced by steel or ropes and cables will be ripped off of buildings, as you saw in that video. Almost all trees will be destroyed. The storm surge will be massive and will flood all low-lying coastal towns and villages. The salt water that floods over the land after a Category 5 tropical storm will kill plants and destroy farmland, contaminating land and preventing farming for a long time. People will be forced to evacuate, and those that remain will have to secure their homes very well and will have to remain on the upper floors of their homes to prevent drowning from flooding. A Category 5 tropical storm is a relatively rare event, but they do happen every year and increasingly often. So this is how tropical storms are measured. Let me show you a video that helps to explain further what the impact on a single home might be from these different categories and how people might respond differently to each one.
When it comes to hurricanes, each one's impacts are a little bit different, but the wind speeds that we talk about along the Saffir-Simpson scale, those are very specific, and the damage kind of predictable. So let me show you. Let's start off with a Category 1 storm. And the damage here, not too bad. A couple of shingles fall off, you can have some palm fronds bending in the wind, but everything basically remains intact. Category 2, that's where you really start to feel it. Look at the windows of the house. They can be hit from debris from the outside and already start breaking in a Category 2. Your trees are significantly bent over in the wind, and the siding of the house itself can break, flapping there in the wind, adding to those.
Make sure that you're writing notes throughout this video for each category to help you understand the damage that it causes and what people should do.
Eerie noises inside. Category 3. I've heard only a Category 3, but it's not only anything except really bad news. In a Category 3, you can have the door of the house blown in because the winds get so strong. You can have the roof of the house start to flap up and down in the wind because it can lift off those weak points, and a lot of those trees start to fall. Category 4, the damage is even worse. You get most trees falling, most of your windows breaking, most of your shingles fly away, and then Cat 5 is as high as the category scale goes. By Cat 5, no shingles remain anywhere nearby. The holes in the roof get so big that the walls of the house start to fall because they're not attached to anything anymore. There won't be any trees up in the neighborhood. That's just catastrophic damage. But again,
this video should have helped you to understand the Saffir-Simpson scale better and the different levels of damage being caused by each scale. Please make sure that you've written key notes about what people should do and the damage caused by each category on the Saffir-Simpson scale. Think about, in particular, how the responses would be different from Category 1 to Category 5. Category 1, there might be some individual preparation for the storm. You might get emergency supplies such as torches and water and medicine. But all the way up to Category 5, you're talking about whole cities being evacuated. Only people who have very, very advanced medical supplies and emergency kits, they've secured their roofs, will be able to cope in a Category 5 storm. Being outside would be deadly, and having any loose objects in the street would be equally threatening to human life. The economic damage from a Category 5 storm is almost always above billions of dollars when a Category 5 storm hits a city. Time to assess learning. Question 1. How does air pressure determine the category of a tropical storm? The lower the air pressure, the faster the winds will be, because winds and wind speed is determined by the difference in air pressure between two places. So the lower the air pressure beneath the storm, the faster the winds will be, and therefore the higher the category of storm it will be. Question 2. Next question. What is the difference in damage between a Category 5 storm and a Category 1? Give me some examples. Well, a Category 5 storm, you should have said, has the greatest possible damage from a storm due to the fastest winds, heaviest rain, and highest storm surge. So that in a Category 5 storm, roofs will be destroyed, whole buildings may collapse, there will be extensive, which means widespread flooding, electricity will be taken out, cars will be moved, ships may be brought ashore by the storm surge. You may have sewers overflowing. In fact, you'll almost certainly have sewers overflowing. So the damage in a Category 5 storm is devastating. Whereas in a Category 1 storm, while there may be damage to individual buildings due to loose objects, it's much less likely that there'll be a storm surge that actually affects a city widely. And reinforced buildings, in particular, will remain largely unaffected. Time to embed learning. Read the questions, answer them using your understanding, and then mark your answers. Number 1, air pressure and wind speed. 2, this is an interesting question because you need to understand how governments react to different tropical storms differently. So the higher up the category scale on the Saffir-Simpson scale, the more a government will respond to the tropical storm, with massive evacuations happening higher up the scale and more individual responses happening lower down the scale. 3. 2 differences in home preparations. You could have had any number of differences, but I've given you 3 here. So you should have focused on the amount of work that's needed, the supplies that are needed, and the kinds of communication that you might need. Please mark your answers and give yourselves a score out of 8. If you got 6 or more, excellent. Please repetitively test yourselves on these questions until you've memorized how to answer these questions for the future. In green pen, add any corrections or missing parts. From this lesson, write 2 questions. Answer them from memory, and then in a week's time, mark your answers. Next lesson, I'm going to introduce our case study of a tropical storm, Typhoon Haiyan, which hit the Philippines in 2013. Join me then.